This is Tim Haggerty with the Virtual Training Company, and we're doing our C++ fundamentals videos. We are going to take a look at a brand new concept, a brand new fundamental for C++, something you did not ever see in C before, and that's called a function template. A function template allows us to create a function that will accept different types as input, not just values. It used to be when we had to write a comparison or a sort or something like that, we'd have to write one for strings and one for characters and one for integers and one for floats and so on. Well, now we can use a function template, and when we use this template, we can say that when this function is called, that it can take in different types. It's very, very powerful. For example, down here we have a example, and the template class identifier function declaration, that's what it looks like, and template type name identifier function declaration. They're basically identical. There's no real difference in them. I think it was for a compatibility with a different version or a different flavor of language that was brought into C++, but we'll just use the term class just to keep it consistent. So down here we have template, class, and then my type, and you're going to find out that that's usually just a capital T for type. That's most of the time what they use here. Then the actual definition is here. My type, that's going to be the same value from there. So if that's a capital T, or in our case just my type, that will come through here, and that is saying that the getMax function, here's the actual function that we're defining here, that, or declaring at this point, that getMax will return whatever the type is. And here's the type from up here. So let's say that this is an integer when we use it, and we're going to use it in a minute. I'll show you some code here. Then the getMax will return that same type. It will also take in two values, A and B, also of this particular type that gets used. In this case, the word my type, that's just the identifier, but that will be an actual type, like an int or a char or a float or a double or even a class. And we're going to see that in a couple of screens here, or a couple of videos actually, that there are class templates too. But right now let's stick with functions. So we have the type A and B are going to come in, and then this is simply going to do a return, and it's going to do a tertiary operator, and it's going to do the test, is A greater than B, and if that's true, return A. If it's not, return B. So either A or B will come back out of this, one of these two values, the bigger one, because it's called getMax. And when that return is performed, it will come back as whatever this type is that's coming into us. Okay, very simple. Let's go over and take a look at some code here. And here's all the standard stuff. And here's our template. Template class T. So there's that T that I told you about, and the compiler knows that this is a template. And here's getMax, and it gives us a little information that getMax will return a T. It will take in a T. It will take two T's, whatever they are, A and B, on the way in. And here, getMax will create a result, and then the result will be equal to the comparison operator, and then we'll return that result. Basically just what we showed before. Now here it is in use. Here we set up a character A. We set it equal to a constant A, B, and X is going to be our return value, also a character. We set an int of 5 and 6 and a long of 10 and 5, just for numbers to put in here. Now here's how we're going to use this thing. Here we say K is equal to getMax type int. See the less than and greater than? Those are the characters you want to watch out for. So getMax is of type integer, and here's our I and j. So when this gets used up here, the getMax, we've said that this is going to be an int. So now wherever you see the type name T, replace that with int. And the compiler does all this for you. You don't have to do this. That's the great thing about the templates. Here we use it for longs, and is the getMax of longs, L and M, which are our two guys here. And then we use the character one. But you know what? There is an implied template version here as well. We can, if we leave off this int and long and so on, the compiler will figure it out. The compiler can look and see that A and B and X are all characters. It understands how the template is created using the same class all over, and that will imply characters, and that's exactly what it will do. And then here's just the cout that will print the output. So let's run this. And 6, 10, and B. Those are the larger values of all three of those. It did exactly that with just one piece of code. So those are function templates. Very powerful, something to take a much more in-depth look at as you start to get into really doing some programming beyond fundamentals. So a great way of separating your ideas from your actual code so that you can have one idea and let it work on multiple different types. That's really the power of templates.
Hi guys, welcome to the C++ programming tutorials. So in this tutorial we're going to learn about the templates and the generic functions in C++. So let's say in your program, you have to write a function, which is going to work on the integers and the floating point number, and it's going to do the same thing. For example, you need to write a function, which is going to check for two numbers and it's going to return the largest number. So what you can do is we can write the function with the same name and different type of parameters. For example, let's say int, and I'm just going to call it as max, that int is return type, and here it can take two parameters, int x comma int y, and it can return, and we can check whether x is greater than y. If it is so, we're going to return x, else we're going to return y. So now this function can work on integer type of data. And if you want to write a function with the same name and you want it to work for the floating point also, what I can do is I can copy this, paste it here, and I can change this data type to float. Okay, now we have written the same function, the same logic, but for different data types. So we can use that in our program. So for example, let's say max, and I'm just gonna pass two numbers, let's say 2, 4 or whatever it is, and I'm just gonna build and run, and we get 4. Now I can pass floating point number also, 2.23 and 2.12, and if I build and run, you guys can see we get 2.23. Alright, now we have overloaded this max function, or we can say that we have written the same logic two times, just to make it work for different data types. So what if we can write this function only once and make it to work on different type of data types? So we can do that in C++ by using the templates and the generic functions. And first of all, what is a generic function? A generic function defines a general set of operations that will be applied to various types of data. For example, here in this case, if we can able to write a function which can work on these integers and the floating point numbers, then that function is gonna set to operate on different types of data, and that function is called a generic function. The type of data that the function will operate upon is passed to it as a parameter. Just like the way we are passing the parameter to this max function here, we're gonna pass the type of data that our generic function is gonna operate. So we can say that through a generic function, a single general procedure can be applied to a wide range of data. So the next thing you guys may ask me, like, okay dude, what is the use of this generic function? What happens, or why we need to write a function which can work on different types of data? Normally in programming, in many cases, many algorithms are logically the same no matter what type of data they're gonna be operating on. For example, let's say you have to write a quicksort application where the logic or the algorithm is same, whether you are using an array of integers or an array of floating point numbers. But the only thing that differs is the type of data that we're gonna be working on. In this quicksort example, if we were able to write a generic function, then our generic function is going to define the nature of the algorithm independent of the data. So once we have done this, the compiler will automatically generate the correct code for the type of data. When we pass integer type, it's gonna make that generic function to work with integers. When we pass floating point values, it's gonna make that generic function to work with the floating point numbers. So in other words, we can say that when we write a generic function, we are creating a function that can automatically overload itself. And if it is confusing, don't worry, when we see the example and when we use the generic function in our programming, it's going to be very clear and easy to understand. Alright, to write a generic function, a function which can work on any type of data, we need to use a keyword called template. And then we need to write a less than symbol and a greater than symbol, and between that less than and greater than symbol we need to write a keyword. It may be a class, the keyword class, or it may be type name. You can use either class or type name. Both of them are gonna do the same thing. And then after that keyword we need to write an identifier that the function that we're gonna define is gonna be working on. So here just an identifier, it can be anything, any name you want to give, you guys can give. For example, let's say identifier, and then we need to write the function, just similar to any other function declaration. First we need to write the return type, and then the function name, and then in parentheses the parameters that the function is going to be working on, and then the function body. So here these parameters that this function are going to be working on are going to be of type this identifier. So if it is again confusing, don't worry, when we see this in example, it's going to be clear. Alright, now in this tutorial, for the demonstration purpose, what we're going to do is we're going to write a function which is going to print out whatever values we're going to pass to it. It may be an integer value, or it may be a floating point value, or it may be a string. Whatever we pass it to the one function, is going to print it out. So we're going to write the generic function right now. So first we need to write the keyword template, and then we need to write less than symbol and greater than symbol, and here we can use either class or type name keyword. I'm going to write type name, and then let's give a name to the identifier, let's say my type, and then we need to write the return type of the function. Our function is not going to return any values, so it's going to be void, and then the function name, let's say display, and then in this parenthesis we need to pass the parameters. Let's say our function is going to take one parameter. So here this my type is a placeholder name for the data type used by this function display. So we don't know what type of data it's going to be taking, maybe integer, float, or string. So we're going to refer this placeholder here. So it's going to be my type, and then the variable name, let's say x, and then we're going to define the function body. So here I'm going to use a cout, and I'm just going to say you have passed, and then I'm just going to refer to this x, and then we're going to end this line. So that's it. Now we have defined a generic function by using the templates which can work on any type of data. So I can use this function display now in my program and pass any type of data. So here for the demonstration purpose we're going to call this display function. So now in our program we're going to call this display function and pass the parameters. So I'm going to write the function name, which is display, and then I'm just gonna pass an integer value. Now when we compile this code, the C++ will come to know that okay, this display function has to work with integer type of data, and that's why it's gonna make it to work with integer type. In other words, we can say that this my type is gonna refer to the integer type, and I'm just gonna build and run this, and you get you have passed 10. Now we can use the same function and pass floating point values, string values, double values, whatever we want. I'm just gonna pass 1.2345, and here I'm just gonna pass Anil Shetty rocks, and I'm gonna add the codes here, and I'm just gonna save it, build and run this, and now you guys can see you have passed 10, you have passed 1.2345, you have passed the Anil Shetty rocks. The same function, it is working on different types of data. So here we have written a generic function which is working on different types of data. So we can say that a generic function defines a general set of operations that will be applied to various types of data. And to create a generic function in C++, we're going to use the template keyword, and this is how you guys can write a generic function. So this is it, guys. This is about the generic functions and templates in C++. Thank you for watching, and don't forget to subscribe. In the next tutorial we're going to be learning some more about the generic functions in C++, and I'll see you in the next tutorial.